What's up everyone? In today's Java Basics video on the Future Programmer YouTube channel, you'll learn about modifiers, a concept that is very useful in, but not limited to object-oriented programming. So without further ado, let's get into it. Have you ever wondered what modifiers such as public and static are, and when should we use each of them? Well, this lesson today is on modifiers and how to use them to modify methods, attributes, and more. Modifiers can be categorized into several groups, and today we're going to mainly focus on access modifiers and the non-access modifiers static and final. Access modifiers determine how and where something can be accessed, and the two we're going to worry about right now are public and private. Just like the name suggests, public makes a variable, method, or class accessible to all parts of the program, whereas private makes code accessible only to the class it is in. You can think about a class as a house. Public things, public attributes, and public methods are information that can be accessed from outside the house, whereas private methods and private variables can only be accessed within that same class. For example, here we have a class called city. In here we have two instance attributes. The first one is a public string called name, and the second one is a private int called population. In the constructor of the class, we assign two parameters to their respective instance attributes. Now, in the main class, we create a city instance where we pass in a string and an int. Here are the places where we access the name and population instance attributes. Now, if I copy this program into the online Java editor from Replit and run it, we'll see that we actually get an error. And that is because population has private access in city. This is telling us that the population instance attribute was declared private, which means that we can only access this instance attribute inside of the city class. So trying to access somewhere.population is not going to work. So if I remove this line, we'll actually see that our program will run successfully. And we see city, which is the name we gave our city. Or another thing I can do is make this instance attribute public. So instead of private int population, I can write public int population. And we can see our instance attribute 1, 2, 3, 4, 5, which is the value of the instance attribute population, got printed out successfully. So that's the deal with public and private. Public makes things visible to the entire program, whereas private makes something only visible to that same class, within the class of that something. In the next lesson of this course, we will talk about encapsulation, which is another very important concept in object-oriented programming. That is the restriction of data access from across classes. We'll also discuss how to access and modify private instance attributes like population right here. Public and private can also be used to modify methods, not only variables, but also methods. A private method can only be called from within the same class, whereas a public one can be called from anywhere in the same program. Some modifiers do not actually modify access control, and the two we're going to focus on today are static and final. The keyword static changes whether a method or attribute is of a class or of an object. Now remember that an object is an instance of a class, so it's something created from the class. It's something created from the class blueprint. A non-static, which is what we have been using for our methods and attributes, these are known as instance methods and instance attributes. So non-static instance methods, for instance, they must be called from an instance of the class, which is an object of the class. Whereas a static method, it can be called directly from the class without creating any objects. So think about an instance method, a non-static method, can be called only from an instance of the class, whereas a static one can be called without creating any class instances. So here we have a somewhat complicated class right here. So we have a class called store. It has two private instance attributes, name and ID, and we have three public variables. These public variables are all modified with the modifier static, which you can notice goes after public but before the data type. So public static int numStores is initially set to 0. Public static int next ID is set to 1. And public static ArrayList store, which is a variable called stores, is a new ArrayList storing stores. In the constructor, what we do here is we take one parameter called name, set it to the instance attribute, and use this.id, so this is the instance attribute ID, is set to next ID, which is the next available ID number for a store. And then we call stores.add this. So we're adding this instance, this object, to our array list. So you may have noticed that these are actually not, they don't belong to an object. They belong to the class blueprint. It belongs kind of to the factory of our objects. So these are information that can be accessed from any of our class instances or from the class directly. So we can use these values when creating our class instances like we do here. So we're assigning this.id to the next available ID number, and then we add 1 to our next available ID. So the next time we create an object, we'll use an ID that has not been used before. And stores.add, we're adding an object to our array list. So we're keeping track of all the stores we have created inside of the class. So we're using a public static, which is a class variable, to store the objects we have created previously. And numStores is also a variable that belongs to the class store. So we're storing how many stores we have opened so far. We also have two instance attributes, the first of which is a void, well, both of them are void returning public methods. The first one is an instance method, so it does not have the static modifier. And we write print information. So this method is going to print out information about the current instance. It's going to print out the name and ID of the current object. And this is a public static void returning method. So this can be called from the class in addition to the objects. So we're going to call, for instance, store.closeAllStores, and it will print out all stores have been closed, and we'll reset the number of stores we have opened to 0. We'll change the next ID number to 1, and we'll call the clear method on stores, which is the array list right here. In our main class, in our main method, we first print out the number of stores of store. Now notice here, we write store, which is the name of our class. We're referencing the numStores variable of our store class. This is a static variable, so we can access it directly from the class. And here we have store1, which is a new store. We pass in a string name, and we print out store.numStores again, which should now be 1. Same thing here, so now our numStores should be 2, because we have 2 stores. And the reason why store.numStores has been incremented every time is every time we call the constructor of this class, numStores gets bigger by 1. So does next ID, and stores gets longer. So we're adding store1 and store2, these objects, to the store.stores static attribute. So here, when we print out for every store S, every store object inside of the stores array list, we'll print out the information about each object. So we're calling the print information instance method of the object. We're calling the instance method of an instance. And lastly, we write store.closeAllStores. And the reason why we can do that directly from the class is because closeAllStores was declared to be static. So remember, static things can be called from the class, and non-static things must be called from an instance of the class. So let me just copy this code into our editor. And before that, I'll actually have to import java.util.ArrayList. So now if I run this program, we should see 0, 1, 2, which are our num stores values. So store.num stores should give us 0 initially, perfect. And then store.num stores gets bigger by 1 because we created one new instance of the store class, so we get 1. And then we create another store, so now num stores should be 2. And here we print out the stores. So we have, for each store, we print out the information regarding it. So we print out store name, store 1, store ID is also 1, store name, store 2, store ID is equal to 2. And after we call store.close all stores, we can see that all stores have been closed. And let me just check. What if I do system.out.println and I print out store.num stores, semicolon. So we see after all stores have been closed, we now have a num stores value of 0. Some variables are constant, like mathematical constants, and that means that they are not meant to be changed after initialization. The final modifier in Java makes it so that modifying a variable will raise an error, telling us that we're trying to change a variable that we have initially believed that it should not be changed. So if we declare a variable final, it means it's a constant. It should not be changed after being given an initial value. So this way, these variables will not be changed by accident. Constants declared to be final are usually in all uppercase. So here we have just a main class. It doesn't have to be in another class. It can just be in your main, I guess, your driver code. So here we have a final double variable called pi. It's all in uppercase. It's not. I do not believe it is required, but it is good practice to have your constants in all uppercase, and it's equal to the value of pi. And final double e is also equal to a mathematical constant. And here I'm trying to modify pi to be another value, which is obviously not the correct value of pi. And we'll see that this line will actually raise an error when I run it. So let me just run this program. And we'll see error cannot assign a value to final variable pi. Because pi has the modifier final when it was declared, we cannot change its value. It's constant. We make a value and that is its final value. So we cannot change its value. So if I want to change its value, what I can do is I can just get rid of the final and we can change it. To summarize today's lesson, modifiers change how code behave, how attributes can be accessed, how methods can be called, and so on. And it's a very important part of Java programming. You'll certainly apply what you learned today in this lesson in your future programs. And that concludes the end of this tutorial on modifiers in Java. If you learned something in today's video, please consider subscribing to my channel down below. If you have any questions, feel free to leave them in the comment section. And with that said, thank you very much for watching this video, and I hope to see you in more.